So here's the tricky first derivative test one. We're trying to find the local extrema for y equals x arctangent of x. So we start by finding the critical numbers. Y prime is the derivative of x is 1 arctan x plus x times 1 over 1 plus x squared, which is the derivative of arctan x. Now, as you look at this algebraically, it's difficult to think of a way to solve this. So sometimes you just have to look at this and start thinking about values that you can try that may be critical numbers. And the first value I would think about is choosing a simple one such as 0. Notice if 0 is plugged in here, that makes this whole term 0. And arctan of 0 is 0. So we get for arctan x plus x over 1 plus x squared, we get x equal to 0 as our critical number, and only critical number. Try to think of anything else that's defined there, and it's going to be difficult. And if you're not sure, you can always go to your calculator, graph it, and see on the derivative is there anywhere else that the derivative is equal to 0. So we have our critical number. Let's choose values to each side, negative 1 and 1. So we're going to plug those into y prime. We'll call it f prime for the ease of notation. F prime of negative 1, arctan of negative 1, and then plus negative 1 over 1 plus negative 1 squared is 1. So what we get here is arctan of negative 1, you guessed it, negative pi over 4, and then it's going to be minus 1/2, which is a negative number. So we are sloping down to 0. And then f prime of 1, arctan of 1 is pi over 4 plus 1/2. Check it out, it's a positive. So we are increasing. And that means we have a minimum value at f of 0. When I plug in y equal to 0, arctangent of 0, we get y equal to 0. So 0, 0 is a minimum. And there he is, the origin man.